Okay class, this is going to be your tutorial on how to use Tracker. This program is going to help us analyze how our trebuchet is shooting. You're going to go into our class here in Schoology, go to course content, trebuchet unit, tracker tutorial. Attached here, you're going to find the tracker test file. This is where we want to start. It's just a simple video file. It's only 1 second long. Hit this button up here. It says download. We'll download the video. It's going to download to the download folder on your computer. So if you look in your file viewer program here, go into the downloads folder. There it is, right there. Don't click on that. That's just where it's located. So what we are going to do next is open up the tracker program. So for you to find the tracker program, you'll need to click in your start menu over here and just scroll down until you find tracker, and there's your program right there. That's where it is on the computers in our computer lab. Now here's the window. Let's go ahead and maximize the window to get the best experience. So to open up that video that we just downloaded, you're going to click up here in the top left, go to import, and you can find the downloads folder by clicking this drop down menu here, downloads. So there we go, downloads tracker intro lesson test video. Okay, so just open that. So you can see it was a vertical video that Tracker wants to display as a horizontal video. So we're going to do a filter. First thing we're going to do, right click on the video, come down to filter, new, and then rotate. You're going to rotate -90 degrees and then press close. You can use the scroll wheel on your mouse to zoom in, and then you're going to click and drag to move the video around. Unfortunately, when you click and drag and then zoom again, it does all sorts of funky things. So that's until you put some data on here. So what we have here, guys, let's play the video. We're going to see when the machine starts to move. Right after it starts to move, you can pause it. And then this right here is called your playhead. Right click on the playhead and click this option that says set start frame to slider 30. 30 is the frame that we're in. We're in frame 30. And that's what this red number is over here. We're in frame 30. So it's okay if you want to start on frame 30. And then we're going to just watch this video for a minute, press play again. It's going to go through its motion. You see it's in slow-mo because I took a slow-mo video. And we're going to stop right about here. I saw the projectile right there. I'm going to advance manually by hitting this button over here. It says step forward. Click that one more time, and the projectile disappears out from view. So there's no more interesting data. We're going to right-click on the playhead again, and be careful that you hit set end frame to slider, and that's going to be slide 149. The numbers should be the same for you if you want to copy that. It's fine. So now I can hit this black button right here, and that's going to restart to where the playhead is. Okay, we need to do a few calibrating things. So go ahead and zoom in, and then drag that down to the bottom where we're going to see the two wheels up close. First thing we're going to do is click up here where the calibration tools are. So we need to click on calibration tools, and the first thing is calibration stick. So we want to select calibration stick. Now when you're entering in data points in Tracker, you're going to shift click. So that means you're just going to hold down the shift button on your keyboard. And if you look in yellow, it says in the yellow box on our lower right, calibration stick A, shift click to mark end one. And that's how we know we're about to do the right thing. So I'm going to hold down shift. You'll see my pointer changes from a normal pointer to this box. And we're going to center up that crosshairs in the box right in the center of the wheel. By the way, if you click a point at any time when we're tracking something, you can drag it to edit where that point goes. We'll do the second point over here. Well, if you're going to drag it, by the way, you have to make sure you're not holding down shift. Okay, so we want these 2 points, the center of the wheel to the center of the wheel. Now it says that it's 332 meters. That's wrong. So we're going to click on that. It'll highlight it. I want you to type in 24 inches. You can just type in inch, actually. 24 space inch. So it should look just like that, and then press enter. It'll ask if you want to change the length unit to inches, and you're going to say yes. So what we did is we just measured, we told the program, we told Tracker that from here to here in real life is exactly 24 inches. And that is true, by the way. You're going to have to measure your frame and know exactly how many inches it is from 2 key points in your frame. You could even use a marker to put a red mark on the frame to make things easier for you. Okay, now we're going to do the fun part. Up here, this button kind of in the middle of the toolbar says create a new track. So we're going to click that. And we just want to, again, click the first option, which is a point mass. Click on that. Now, before we start putting stuff in here, let's click on where it says mass A over here. So this is this little window. Don't close this window on accident because then things get confusing. Click on mass A and name it. We're going to first track the counterweight. And then press enter. And now we could actually change some more things. Let's do that. So, here we go. Right here at the top, it says counterweight. M is mass. You could actually designate how much mass your counterweight is. So a lot of you have a counterweight mass of like 700 grams. Let's go ahead and type in 700 grams, or it's already in kilograms, so just type in 0.7 kilograms. Press enter. So that'll actually tell us what the kinetic energy is in a minute. That'll be cool. All right, so what we're going to do is, again, you'll see in the yellow box down there, it says counterweight selected, set mass on toolbar, shift click to mark. So we're going to hold down shift and we're going to start clicking. Now I'm going to zoom way in here because I want to be very accurate. And now guys, this is the important part. We must be extremely accurate where we place these markers. So as I click, it's going to advance to the next slide. So you saw that 0. I'm going to click again. That says 1. All right, and you see it moves a little bit. That's because it's actually advancing through the frames of the video. And you'll see that the counterweight is moving slightly. And you want to move with it. So it's very important that you zoom in and move with that counterweight. Now this takes a little bit of time, so I'm going to do it all the way through the motion, and then I'll restart the video. Okay guys, so right here, I've just done frame 70's data point, and now the point that I'm tracking is behind this part of the frame. So I don't want to come up with fake data, so what I'm going to do is step forward. 1, 2, 3, and now I can see my little button there again. All right, so if you can't see something, don't guess, just skip forward. So you see I'm going to do that again, and there's my button again. So what we're seeing here is the deceleration of the counterweight, which is an interesting moment because that's what we'll call the stall of the counterweight. Skipping some frames. So I see that button appear. Looks like it's there. Try not to guess and try not to spam the button. Be very precise. Okay. Now there's a serious stall going on here. Now that stall point is actually really important to identify because that's going to indicate when the transfer of energy is complete. And last one right there. Okay. So now we have, oops, okay, so let's restart this video and play what we have. So you'll see all these points of data appear, and it seems to be tracking right with our counterweight because we put all those in manually. Very good. Okay, so what's the big deal, Mr. Broadway? Okay, let's click over here on some stuff on our right-hand side of the screen. We've got these two modules. We have the counterweight plot up here, and then down here, this counterweight table, it says. So when we do different point masses, they're going to show up in these drop-down menus. But let's actually look right here on, so we've got time on the x-axis, and then on the y-axis, let's click on this where it says x inches. And we want to change what data is being plotted against time. We're going to click on V, velocity magnitude. This is just the overall velocity of our point mass that we're tracking. And when you have that selected and you play the video, you'll see it jumps through all the data points. And you see my data is a little bit scattered where it goes up and down, slightly up and down, up and down. And that's because because it's imperfect and we're zoomed in a little bit far. So what you can do is right click and say zoom out. And now you can kind of see the trend. See, it goes up and then it gets to a certain point and then it drops off. So right here, we can clearly see that this trend line is up and then it stops right about here and it comes right back down. So let's see, I wonder what frame that is. If I click on it, it says it's frame 95 down here. Okay, let's explore the table options for a second. So click on this word table. And in this dialog box, we can deselect X and Y, and we can select V. V is for velocity. And let's also select frame. Frame is going to tell us again what number frame it's in. So it looks like we're in frame 95, and this is how fast it's going at that time. It's going 90.55 inches per second, and you see after that the numbers just start to get smaller. So this is where it's traveling its fastest, and at frame 96 is when it begins to decelerate. That is important information. Okay, so let's keep the table just like this, these two tables, and let's begin to explore another point mass. So we're going to restart the video to step 0, frame 30, and we're going to click Create Point Mass. And this will be mass A. We're going to change two things. We're going to change the name. You can name this beam or arm, whatever you want to call it. It's the end of the beam right there. And then click on arm again and change the color, third option. Let's change it to any other color but red. Okay, so it's going to be blue. So now we're going to track the end of the arm from frame 0 and going forward. So same thing, as long as we got arm selected. So you can see what's selected up here at this point in the menu. So you could select any of the other features that you've put in. We don't really care about what the mass of the arm is. It's going to default to 1 kilogram. That doesn't matter. Okay, so now I'm going to begin tracking the arm. So holding down Shift, going to the very end of the arm, I'm going to begin clicking. Now at this point, I'm not going to make you watch me click. So you go do this, and I'm going to pause the video. And after you've gotten all the way around, you can unpause and we'll pick it up from there. Okay, class, here I am at frame 119 or frame 149, if you want to call it that. It's the last frame that we're analyzing. And yeah, just to show you, you can, if you decided, hey, that last point wasn't quite right, you can change it. Or you can go back like this and fix some things. Okay, so if you're happy with where your points are, then we're going to go ahead and look at that data. So again, now we're on arm. We need to change back to velocity magnitude on the top, and the table we can deselect X and Y and select V and frame. And let's play through the data. You'll see over here what we're seeing is the arm is accelerating in the table. It's going faster, it's going faster, it's going faster, and those are in inches per second. And it reaches a peak right up here, and then it begins to slow down, slow down, slow down, slow down. Okay, so right here is the stall point, right? You've got this massive acceleration. It plateaus for a brief moment, and then it drops off. Now, if I zoom in on that table, you'll see all the ups and downs. Let me zoom back out. You see all these ups and downs, right? Well, I'm not super concerned about all the ups and downs. Let's zoom out if you want to get a bigger overall picture here. So like I had some issues in the middle there, it looks like. Actually, I think what that is because the trebuchet slides forward and backward. But if you look at this overall trend, there's a nice gentle acceleration of the arm, and then it shoots up, and then it peaks, and then it drops off quite a lot, and then you'll see it plateaus sort of over here. So that's very interesting. But let's do this. Let's right click on the plot here and go down to compare with, and then we will select counterweight, or you can hit select all and then say okay. And so here you're going to see the two different plots at the same time, that of the counterweight mass and the end of the arm. Let me zoom in a little bit. Now what this is showing us is just like when we analyzed the counterweight by itself, we saw that right in here it began to decelerate, right? It began to drop off. Hey, look, that's just at about the same time that the end of the beam really goes up, right here in this time, about just under 0.3 in terms of time. That's the seconds that have passed. So, you know, this is accelerating rapidly right as the counterweight is beginning its deceleration. That is showing us the transfer of energy, and that is good that those are lining up the way that they are. We're going to track one more thing to drive this point home, and that is the money shot which is going to be our projectile. That's how you spell projectile. Then let's change the color. Pick a color, any color. I'll pick green. And I'm going to zoom in on our projectile. Now, here's how I want you to track the projectile. Okay, we're going to pretend that the projectile, well, it's not a pretend, like you're going to, like you see that's the blue pouch, right? I want you to click on right where you think the projectile is. So shift click. Oh, didn't have my projectile selected. So select projectile if you need to. Shift click, and then we're going to go ahead and track the projectile. And you'll notice the first few clicks, this projectile is pretty much in the same place. It doesn't really move. Now that's because this is a whipper style trebuchet. And with the whipper, the arm can start to rotate before the projectile has to move at all. So that means the projectile and all the mass that is the projectile doesn't really affect the rotation of the arm. So the end of the arm, which is like 20 or 18 inches that way, is starting to move, but the projectile is barely moving at all. It's going to start to move more and more as we go, of course, and you can see that it is. In fact, let's look at that. I didn't do this before, but let's do it now. If we come over here and again set this to velocity magnitude, and let's zoom out so that we're not, whoops, zoom out, zoom out. Okay, so you can see at first that it trended pretty flat. Okay, now because my trebuchet actually has wheels, the frame is moving to the right, and that's also allowing the projectile to stay sort of stationary. At this point, the arm's beginning to separate, and the projectile has gone invisible here. I don't know where it's at, so I'm not going to guess. I'm going to advance my slides. It's somewhere behind the frame still, until I know for certain where it's at. Okay, you saw in this frame, the pink string is a little bit slack. You see there's a slight bow. And then in this frame, it snaps straight again. So the projectile is somewhere in here. I still can't see it. Okay, now I've got the pouch, so I'm going to go ahead and guess the projectile is here. And now it's here, and now it's here. Now it's here. Okay, now this can be a little bit tricky because the projectile is going to move so fast that wow, look at that. Starting to move really rapidly now. It's going to move so fast that it's going to be a motion blur. So let me back that up one more frame. I want you to put your points right at the furthest point that it is. So the furthest point in space that the projectile was in that frame. So as the sensor of the camera was exposed to light, in that amount of time, that frame time, the projectile moved from here to here. So I want you to select the part of the projectile that's furthest forward. At this point, we really are tracking the sling or the little pouch that the projectile's in. That's okay, because the projectile's inside of it. Sometimes, in order to understand where the projectile is, you kind of have to go advance forward or backward to see where the blurry picture is. This probably would have been better on a white background, but we work with what we got. Okay, so right about here, now we actually see the projectile itself. So from here to here, that's where the projectile was for this one frame. That's why you have motion blur. We're going to click on the end of it. The end of it that's furthest forward in the projectile's trajectory. Those few frames right there are pretty clear. So the projectile has now, of course, left the pouch, and it is soaring on its way out of the frame. This frame is hard to see right here, but it's approximately here. Now, okay, let's go ahead and stop there because we don't want to skew the data. All right, let's zoom back out, restart the video, and we can watch the pretty colors, red, green, blue, go through their motion. And of course, on the chart over here on our right, you'll see the acceleration happen. Massive, massive acceleration. Let's zoom out. There it goes. So you see it really starts to accelerate right here on this frame. What frame is that? Zoom in. Zoom in. It's really right about here. So, oh my goodness, look at that, guys. That is right, just almost right at 0.3 seconds. Hey, remember that time, 0.3? All right, so let's go back to compare with and select everything and say okay. So right here, zoom out again, at 0.3 seconds, that's where things are starting to happen. That's where we've got a massive acceleration of the projectile. That's where we've got the massive acceleration in the beam, and that's where the counterweight starts its deceleration. So even though the massive acceleration in the green, the projectile, starts right around here, its peak acceleration is up here. Now that should make sense to you because between here and here, between this frame, looks like it's frame 100, and this frame, oh, that's frame 129. Yeah, frame 129 and frame 113. So within those few frames, that's when the projectile really does its acceleration. So let's watch that in the video. You see that it's tucked up underneath. It's just now that string has come taut, and that's when it really flings forward. So it reaches its maximum, should be right when it leaves the sling, somewhere right in here. You'll see the numbers down here in the chart, in the table. Look, 848, that's really fast. So just pull out Siri and say, convert 848 inches per second to miles per hour.
848 inches per second is equivalent to about 48.2 miles per hour.
48.2 miles per hour. That's pretty darn fast for a tiny piece of clay and a 1 kilogram counterweight. So this trebuchet does a decent job, I would say. Anyway, this is how we essentially get Tracker all together. And this right here, the screen that we're looking at right now, this is what I want you to submit to me to show me that you know how to use Tracker. So I have over here highlighted in my chart in the table the fastest that the projectile has gone. So you're going to come over here and make sure projectile is what you have selected. Then on the chart up here, I want you to make sure that you right click and say that you're comparing with everything. All three masses are being compared. And zoom out. Do that right click thing and zoom out. Zoom out so that we can see everything. We can see how these things grow together, how the blue accelerates and then decelerates right as the green, or whatever color you selected, is starting its massive acceleration. Go ahead and pause it over here, pause the video at the frame where the projectile is moving its fastest, which in this case is frame 133, as you can see over here. Make sure you've clicked on table and that you've deselected X and Y and that you have selected V and frame. I want you to see all this data. Oh yeah, make sure over here that you've selected velocity magnitude. So all these things need to be done. Now to save this, you're going to click on this button over here and title it. You can put your name on the end and then save as. I don't care where you save it, just save it to the desktop and title it something with your name in it and then press save. And then we're going to submit a screenshot, and this is where you're going to get your grade. This is how I'm evaluating you. You're going to select the snipping tool. On those computers in there, you should find the snipping tool, or else it might, I think it might say something else on your computer. But you can just start typing snipping tool. I think it says something else like snip and grab or snip and draw or something like that. Basically, guys, you're taking a screenshot. So when you do take a screenshot, make sure you just do a full screen snip, and that's going to automatically take that screenshot for you. Hit the save button there. You can save it again to the desktop. You can write Broadway, not Broadway, write your name and then tracker screenshot, and then save that, and then you can submit that to the Schoology assignment. So we'll go back into Schoology, and you're going to click submit, which will say it'll say submit up here. Make a submission, and then attach that file, and you'll be all done. All right, good job. Bye bye.